This is part 4 of our rebuilding a 1948 NuTone model CH4000 Madison chiming clock. In part 2, you saw me disassemble the clock assembly, and all of the gears and everything were cleaned in our clock cleaning solution in the ultrasonic cleaner. In part 3, we serviced the Telecron gear drive assembly, and now, since all of this is done, it's time to put it all back together. All of the gears and everything are cleaned. All of the plates and everything have been cleaned off. They weren't really in very bad shape. We have all the little screws and things we need to put it back together. We have some precision instrument oil to lube things up with a little bit. So let's go ahead and put our clock assembly back together. As we go along and do this, we're going to add a little bit of the instrument oil to pivot points and things like that, because that's what's necessary. This gear remained attached to the clock base plate assembly, whatever it's called, and that's where it's left because it's held on with a little keeper that we don't want to mess around with. Now, when you lube it, this is the first gear that goes back in place, and when you put the instrument oil on it, you don't put it on the teeth of the gear, you only put it on the little pivot points here. So I'm going to go ahead and put just one little tiny drop like that, and we'll go ahead and put this back in place. It fits underneath this one, and the pivot pin fits in the little hole. I've been told that the reason people ask before in other videos, why don't you put oil on the gears, on the teeth of the gears? And you don't do that because it doesn't aid in allowing things to turn freely. This is not like the gears in a differential in a car where there's a lot of stress and it's under a lot of stress and strain and you need the oil and all that kind of stuff. This is a reasonably precise device, and so it doesn't need all of that. So once we put that one in place, now we're going to go ahead and put this one goes on next. This one's going to sit right here like this. And so what we're going to do, straighten that one out. Stay straight. See, it popped out of the hole a little bit. There we go. We're going to put this one has a tube in the center that slides over this shaft right here. So we're going to put a little oil on the shaft. It doesn't require much. We're only putting like part of a drop, and we're sort of smearing it down. And so this sits on here like this. Now this one goes in place. This one sits here, and this has two teeth on each side, and it sits on this little post right here. So again, we'll put a little oil on the post, like that. Doesn't take much. And I'll point out, as I do in all of these videos, as my friend Marv the Clock Guy says, you can't put it together wrong because it only goes back together one way. And also it helps since we have a video of taking it apart, and this is a fairly standard NuTone clock assembly, so I've done this before, so it's not terribly difficult to do. We do need to put in the little flag that tells us that the power has been off in the house, and while it doesn't move too often, I suppose we should put a little drop of oil on that one also, and that sits in here like that. And now the larger gear sits over the top, so we'll go ahead and put a little oil on this piece right there, and that sits in there just like that. And see, the flag moves, and the gears would all turn otherwise, but they're all flopping around right now. Once we've done that, now we need to put the plate back on, and the center shaft right here goes through the bushing in the plate, so we'll put a little oil on that also, on the largest part of it, because that's the parts that's going to be in the bushing. And it's easy to know how to put this because in this little bumped out area here with the round hole, that's the part that the power outage flag shows up through. So we'll go ahead and put this in place nice and carefully, and we'll line it up, and it pops onto the 3 points where the screws hold it in place. So we have the 3 original screws. We'll go ahead and put these back in, because it's always a little bit of a relief when you get it all screwed back together, because now the gears aren't going to fall out. That and like that. Now this is how most early NuTone clocks are made. And right now, with this put back together, this could go in any NuTone, vintage NuTone 1950s clock, and it will work out just fine. And if we turn the knob that we use to set the time through the little hole, you can see the gears turn, which is outstanding. So that part is done for the moment. However, oh no, we have a gear left over. Where does that go? Well, this is a special gear, and this is sort of the heart of the whole chiming clock idea. This is a gear that's not used in any other NuTone door chime that has a clock. This gear is unique to this type of chiming clock. And what makes this gear special is this contact here and this contact here. Now, if you think about it, this clock has to chime on the hour and on the half hour. And to do that, you need some type of part that activates the chimes at the right time of day. So if you notice, these contacts are 180 degrees apart. So for instance, this one could be the contact that makes it chime on the hour, and then this one is on the half hour, and then it goes around as it turns, and it hits this one, and it chimes on the hour again, and it repeats over and over and over again. So this is the one that sequences the chime to make it ring at the appropriate time. So this one has to go in on this spindle on this metal plate. And this metal plate is also unique to this specific chime, and what makes it unique is there are 2 contacts. There's one here and one here, and as you saw in part 2, these are held in place with these fairly complicated plastic and Bakelite sandwich assemblies, and then there's these aluminum pieces that the screws go through, and ultimately there were wires connected to each of the contacts. So this sits on this spindle right here, like that, and as it slowly turns, this contact just touched the contact on the gear, and then as it turns around, the next contact, which is down here, touched this one, and it goes around and around and around. So this is how it knows when to ring the chimes. So this one, this goes back in here. Now, when we took this apart, this was all kind of flopping around, and I wasn't sure why that was, but I did a little bit of investigation, and what I found was, if we just took this like this and slipped this in place and put it in, the gear would not be lined up, the teeth on the gear would not be lined up with the teeth on this larger gear down here. It would fall. There's nothing holding it up to keep it aligned. And what I found was, and you might recall if you go back to probably video 1 and look, this is the motor frame assembly that our Telecon gear drive assembly is going to go back into. And it had some wires connected to it for power, but then there's this black wire, and it's got this piece of copper strap that's kind of formed into a specific shape. And when we took the chime apart, this was just kind of flopping around. It really wasn't connected to anything, and I wasn't sure what it was for. What it turns out to be is this is the piece that goes underneath this gear to keep it held up so it doesn't fall down and become out of alignment. And when we put this in, this is going to sit on here like this, And the reason that it's made out of copper and it has a wire connected to it and it's connected to this terminal of the coil, which is also connected to a source of power, is it's what energizes the frame of the clock assembly, because that's half of a switch. So this is half of the power to the switch, and then these wires for the hour and half hour are the other side of the switch. So by having the three wires connected together, every time the gear rotates and the contact touches one of the contact straps here and here, it makes the chime ring. And that's what makes this all work. So putting this back together is a little tricky, and what I'm going to do is, because when we get done with this, all of the wiring in the chime, for the most part, is going to get replaced, because it's a bunch of janky old wires that other people have added in. It's not original at all. And I've got some really nice, I'll show you here. I've got some really nice vintage looking cloth covered wire. Now this is modern wire, and I don't necessarily know I'm going to use green. I have this in a lot of different colors, and this is commonly available if you look online. But this is modern wire with modern, probably vinyl insulation, the white part inside, but then it has the woven cloth cover over it to make it look vintagey. And this is more appropriate for this type of item than just regular vinyl insulated wire would be. You know, we could use wire like this. This is just standard 22 gauge vinyl insulated wire, and it would work just fine. But from an aesthetics point of view, it doesn't do much for it, but something like this would. And I have this in a lot of different colors, so we're gonna, I think, come up with a color scheme on how to do this. So let's go ahead and put this back together. What I'm gonna do is, for right now, I'm gonna clip this off. And what I'm going to do is, I left a little nub of the black wire on this coil contact. That's just a reminder to me of that's where it went. Also, it's in the video, so I can always go back and look. So what we're going to do is, this is a little tricky because this is all ends up being upside down. Right now this is facing up where it should be facing down. Before we do anything else, what we're going to do is we're going to put a little oil on the spindle, like that, and we'll put this on here. This is a little floppy, maybe not too bad, so hopefully it will work out all right. So now what we have to do is put the strap here. See, there's nothing that holds the strap on, it just sits over the end of the spindle. So now we have to flip it upside down and put it on the back of the clock base. And to do that, we will try really, really hard to keep our big fingers out of the way. This goes, so this actually, the strap actually sticks out on the right-hand side of the plate. And then, see, there's this recessed tab right here that has to slide under this plate, which makes it all really kind of tricky to do. So if we go like this, and we push it down, that's pretty much how it's supposed to be. Now I'm going to hold that, and if you recall, if you go back and look at, I think it's part 2, there's a washer that goes right there, and then there's a screw, a machine screw with a split washer. This is just a flat washer, which its purpose is to put pressure on this plate. When you tighten it down a little bit. So we'll just snug it down for a second. And then this one down here, this other opening for a screw, if you remember from part 2, it had a screw with a little keeper on it, a little washery kind of thing it threads into. I think it's called a Tinnerman nut, but I'm not positive about that. So we'll undo that. And you notice how I put that together when I took it apart. That way the two halves don't get lost, and it makes it easier to remember. So we'll go ahead and get this lined up like that. We'll put the screw in, and now we have to try to reach up under there and get this to work. So how we're going to do that is we're going to take a screwdriver and we're going to use a magnetizer, and we're going to magnetize the screwdriver a little bit, and then we're going to find something to prop it up on just a little bit so I can actually see under there. And if we did it right, the keeper now sticks to the magnetized screwdriver, and you can carefully reach under there and line it up and turn the screw. And if you're a little bit lucky, you can get it to start. Not being so lucky yet. Let's try it like that. Because see, I can't get my big giant fingers in there because it's too small. So that doesn't work very well. So let's try it a different way. See, it pushes it down and it flips off and it falls over and it's a pain in the neck. So we'll try, I've got the little needle nose pliers which hold it fairly securely. And all you got to do is get part of a thread. So you can feel it go chunk, chunk, chunk every time it spins around. But it's kind of tricky. Nope, not yet. Alright, so I have to see, and maybe you don't get to. Uh-oh, where'd the clip go? Hold on a second. Okay, after a lot of horsing around with it, I actually got it onto the end of the screw. So now I'm going to put my finger in there, because I can do this part now, and tighten this down. Putting your finger in keeps it from spinning. Now the other thing we have to do is, this gap right here, I think should be, the two pieces of metal should be parallel to each other. There should be an even gap, not tapered. So we'll loosen up this top one a little bit and we'll slide this out just a bit to make it line up. And if I'm not mistaken, that's what moves the gear, the upside down gear. It moves it this way and meshes it into the other gear. So now if you look really carefully, let me get a flashlight, and you look inside, which maybe you can see the upside down gear. You saw it there for a second. We're having a hard time with the focusing here, but you can see the upside down gear is meshed into the other gear. Kind of hard to see with the focus problem, but that's all right. So now if I turn the adjustment, which turns all of the gears, it also turns the upside down gear, and that's what we're going to call it from now on. It's the upside down gear, and it all turns together, which is good. Alright, so now our clock assembly is reassembled, except for the motor's got to go back on. Oh, and just as a point of interest, you can see the red flag through the opening because the power has been out because it hasn't been hooked up to anything. If we pull down on the adjustment, it flips it back up to gold, but since there's no power, it goes right back to red. It won't do that while the clock is running. Now that we have the clock assembly put back together, we need to go ahead and complete it by putting on the Telechron motor assembly. So these are the parts for that. We have the frame assembly with the coil. We have the Telecon gear drive assembly, 2 screws, the all-important data plate that tells us which one it is, and the spacers or standoffs that make sure it stays secure. So when you put this back on, you know which side of the frame goes down because it's got this long threaded screw right here, and that fits into this hole in this bushing when you mount it in place, and that helps keep it from twisting around when it turns on. The Telecon gear drive assembly, when you put it in place, And you have to keep track of this or check it when you put it in place. You just press it into the frame, and the gear on the gear drive goes nearest the coil, and it has to be perpendicular to, which means at a 90-degree angle, to the coil assembly, so it fits in the hole right here. And getting it in the hole sometimes is a little tricky because you don't want to mangle up the gear, and it sort of sits in there. When it finds its spot, it'll just pop into place. And like I said, you have to get it perpendicular, otherwise it doesn't fit right. See, it was off a little, and then I straightened it out, and then it just popped right in place. So once you've done that, you take one of the spacers, and they go right in here between this hole and this little brass bushing, which is threaded to hold the screw, and you just sort of slip it underneath. And it's a little hard to do, especially when you have big fingers, so we'll try to do it this way so you can see. It slips in underneath, and you might have to tilt it up a little bit. This is one of those kind of things that when you figure out how to do it, it's always easy. And of course we have to put the data plate back on before the screws, because the screws hold it in place. So we'll get the first screw in, and we'll just start it a little bit. We don't want to tighten it down all the way. And then we'll get this one in on this side. And the purpose of these is primarily just to hold it in place, and when you tighten the screws down, you're not flexing or stressing the frame of the motor. Like that. And when you tighten the screws, you don't need to really wrench on them, you just need to snug them up, because that will be fine. So that's in place. And if I look inside, it's a little hard to show you. I can see that the gear seems to be meshed correctly. So that takes care of that side. Oh, one of the things I noticed on this is where the upside down gear meshes into the large gear on the clock assembly, there's actually this opening right here in the plate, and if you look inside, you can see the teeth of the gears and how they mesh up, which is kind of interesting. I don't know if that was done for alignment or whether it's just a byproduct of the way it was made. If it's for alignment, then what you could do is you could loosen this screw at the top, which allows the plate to pivot back and forth, and that would adjust the alignment of the teeth. So we'll play around with that later on. Once we've done all of that, it would be nice to know if it actually works. But you can't really tell that easily unless you have hands on it. So we're going to temporarily place the hands back on the clock so we can power it up and see it run. So we have our 3 hands here: hour hand, minute hand, and second hand. And these are reasonably delicate. They're made out of stamped metal. You have to be really careful that you don't bend them, because it's easy to do that if you don't handle them carefully. I have had people in the past ask me, how do you put these on? How do you take them off? And it's actually fairly simple. On the end of them, there's a round opening. And if you look really carefully right there, sort of at your 1 o'clock-ish, there's a little slit in the circle. And so when you push this down over the spot here where it fits around it, it will stretch it open just a little bit, and that gives you sort of a friction fit and helps hold it in place. The area where the hands fit onto, the surfaces that they contact get increasingly smaller, so the hour hand has the biggest opening, and that goes on first. And all you really do is you sit it over the end like this, and you very carefully with your fingers press it in place. And that's all you have to do. It's not really terribly difficult. And then we'll do the minute hand. Like that. And lastly, we'll do the second hand. Now, these hands on this clock are flat. Some NuTone clocks the hands have a little bit of a curve to them. Whether they're flat or whether they're curved, you have to be aware of that, because as they go around, if they're bent out of shape, they'll interfere with each other, and like the second hand will get caught on the hour hand or the minute hand. The hour hand is not usually much of a problem, although in this one, if I look this way, if you look, you can see it's sort of tilted down a little bit. So it's actually almost touching the metal plate, and that's not really what you want. You want it to be parallel with the plate. Of course, this is only for testing right now, so you would make all of your final adjustments at the very end when you put the clock all back together. So let me go ahead and get some clip leads, and we're going to hook this up and make it go. Got it hooked up to my bench power supply. We're running it on 22 volts AC because it's a 20 volt motor, and if it was running on the standard NuTone transformer, the transformer would put out about 22 volts. It will drop slightly, but the clock doesn't draw much current, so it's not going to change very much. So we can go ahead and we can actually set this right now, and you kind of have to, since there's no numbers, you kind of have to do your best guess on aligning it at the moment. So there's the minute hand, which is about 12, and the hour hand, if this is 6, this is probably 7, so it's pretty close. It's not quite 8, because this would be 9, so 8 would be in the middle, so we'll just scooch this up a little bit like that, and now it's 8 o'clock. Not that it makes that much difference, but you know. Oh, I'll tell you what we're going to do. We're going to make it quarter after 8 for a reason. Alright, so now it's 8:15. Almost time to watch Gunsmoke, don't you think? Alright, we'll go ahead and power it on. Second hand should move. And there it goes. Now what I usually do with these is once I get them put back together and they've all been serviced, I'll leave it hooked up like this. I'll put it on the little workbench and I'll let it run for a full day just because that's what I like to do. One of the things I will show is we still have our red flag showing in the opening because the power has been off, but now the power is back on. So if we pull down on the adjustment shaft, it changes to gold, and if I let go, it will stay gold, because the clock is running, and then it does that. If you were out at the supermarket and you come home and this is your only clock and you had a power outage, what you'll see on the indicator here is that it'll be red. It falls better when the clock is designed to be straight up and down, vertical, not laying back like this, but that's just to show you how it will flip. So you would come home and it would be red and you would go, oh no, then you don't know really what time it is, and if you're lucky you have a wristwatch so you can reset it. If you don't, then you got to call Popcorn and find out what time it is. Did they have that in the 50s? I don't know. Now we're gold again. So that's pretty much how you put the clock assembly back together. The next upcoming part, we're going to deal with the resonators and the tone bars, and I'll show you how to do that, and we're moving along nicely. I hope you found this interesting, and perhaps for some of you it will be helpful. If it is, please give it a thumbs up on YouTube, because that helps us just a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.